In this particular situation, we have that a biologist studying a colony of bacteria determines that a certain culture grows exponentially, such that the bacteria doubles every 4 days. If initially the biologist has 1,200 bacteria present, how many days does it take before 100,000 bacteria are present? If we have, I'm going to use P for population. If we have P of 0 versus P of 4, what we have is that P of 4 will be 2 times P of 0. In other words, this says that P of 4 over P of 0 is equal to 2. And here again, remember, this is an exponential situation. And we already know that there is also a fixed ratio involved here. In other words, if the value of a function, when the function is exponential, is such that we consider the ratio of the value at 4 over the value at 0. And if you notice, 4 and 0 are 4 steps away from each other, then that means that 2 is going to be equal to b to the 4th. That was the idea of a fixed ratio. I will also make sure to link that video in the description box below if you wish to review that concept. So if the two values are 4, if we're considering two values of the function where the x's are 4 steps away from each other, then that means that the value of that ratio is equal to b the base to the exponent 4 corresponding to the 4 steps. And this is huge because now I know that b to the 4th is equal to 2, which means that I can easily get the base of my exponential model. It's going to be equal to 2 to the 1 over 4, just like that. And look at this. They also gave me the initial amount of bacteria, 1,200. So I practically have the complete model. Now I know that P of t, which should be a times b to the t, is going to be equal to 1,200 times 2 to the 1/4 to the t. And remember that exponents multiply each other. So having 1/4 times t is the same thing as saying t over 4. So I'm going to write that P of t is equal to 1,200 times 2 to the t over 4. And here is my model. Now that I have the model, I think I can solve the question. How many days does it take before 100,000 bacteria are present? So just as before, we set the value of the function equal to 100,000 and then we solve for t. So we're going to have here that 1,200 times 2 to the t over 4 is going to be equal to 100,000, just like that. Now, in order to isolate, we will divide both sides by 1,200 and the same thing over here. So on the left, they'll cancel out. And on the right, I can cancel 2 zeros, just like that. So now I am going to have 2 to the t over 4 is equal to 100 divided by 12. Actually, no, it should be 1,000 divided by 12. And what I want to do now, just like before, is to bring the exponent down because that's where the variable is. So I'm going to take the log of both sides. That means that we're going to have t over 4 times the log of 2. I'm also applying the power rule. I'm doing 2 steps, 2 properties of logs in 1 step. When I take the log of both sides, the next step is to bring the exponent down in front of the log. And that will be equal to the log of 1,000 divided by 12. And now, when we divide by log 2, I will be able to cancel the logs on the left, and I'm going to have t over 4 equals to the log of 1,000 divided by 12 over the log of 2. And my last step is to get rid of this 4 that is in the denominator. In order to do that, we're going to multiply both sides of the equation by 4. So then 4's will cancel on the left, and t will be log of 1,000 over 12 over the log of 2. All of this times 4. Now you get your calculator, you input that expression, and when you do that, we should get that t is going to be approximately 25.5 days. So it will take approximately 25 days and a half for the population of bacteria to be 100,000. In this situation, we have that the isotope random 222 decays exponentially with a half-life of 3.825 days. How long will it take for 80% of the isotope to decay? 80%. By giving us the half-life, they are telling us that it will take 3.825 days for the original amount to drop to half its original size. Now, we don't know what was the original amount, so we have flexibility here. I can actually let it equal to A if I want to, or I can just let it equal to 1, like saying 100%, the original amount, the full amount. So I'm going to keep things simple, I'm going to let it be equal to 1. So originally, we're going to say that f of 0 is equal to 1. Okay, so 100%. But then f of 3.825. So at 3.825 days, that amount is not 1 anymore. That amount is exactly 1/2, because they told us that 3.825 is the half-life. By telling us that it's the half-life, they're telling us that now at this particular t value, the value of the function is half of what it was originally. So if it was 1 originally, it will now be 1/2. So this is now given information, and we know that this is an exponential model, so f of t will be equal to a times b to the t. And for us, remember, we are letting a be 1 for convenience, so that's just going to be 1. That means that we're just going to have b to the t. So our goal is to find the value for the base. In order to find the value for the base, I'm going to be using this point that I have here. I know that f of 3.825, so f of 3.825 is equal to b to the 3.825, which is equal to 1/2. So then that means that I can now solve for b. See, b to the 3.825 is just equal to 1/2, and I can isolate b by considering b equals 1/2 to the 1 over 3.825, just using properties of exponents. And now that I have b, I have the model. Now the model is going to be 1/2 to the 1 over 3.825. That's the base, right? But then all this is now raised to the exponent t. Remember that all this is the value of b. And remember that now we can simplify a little bit because exponents can multiply each other. So I can nicely say that f of t is equal to 1/2 to the t over 3.825. And this is now the model that is representing this situation. Now I can answer the question. The question is, how long will it take for 80% of the isotope to decay? So if 80% decays, then 20% remains. This is like in the previous examples we were doing. If you take 1 minus the rate of decay, 1 minus 0.8 will be 0.2. So then the question is, when will f of t equals 0.2 of what it was originally? And we're saying that originally we had 1 for the original amount. So 1 times 0.2 is 0.2. So for that, we're going to go ahead and take the function, set that equal to 0.2, and now solve for t. And because t is in the exponent, we're going to log both sides. So we're going to have t over 3.825 times the log of 1/2. That is going to be equal to the log of 0.2. Now, we're going to go ahead and divide both sides by the log of 1/2 in order to start isolating. The logs will cancel on the left, and on the right, we're going to have t over 3.825, that will be on the left, and on the right, log of 0.2 over the log of 1 over 2. And now all that we have to do is multiply both sides by this number. So then t will be equal to the log of 0.2 over the log of 1/2, all this times 3.825. And when you enter all of that into your calculator, you should get that t is approximately 8.9 days. Okay. So it will take about 8.9 days for 80% of the isotope to decay. All right, folks, I hope you found this tutorial on solving math applications involving exponential models helpful. Remember, these types of problems are not as complicated as they may seem at first, and with practice, you can become proficient at solving them. If you have any questions or suggestions for future videos, please leave a comment down below. Also, remember to like and subscribe to my channel for more math-related content. Thanks for watching, and I'll see you in the next video. Bye, everyone.